Alright, what is up you guys? So this is going to be the first tuning video in this new series where I'm doing some very detailed tuning videos. So for this video, I'm going to go over how to set up a bass tune. Let's say you installed some parts on your car and your car won't run because your bass tune is not set up. So this is going to be kind of things that you can change based on what mods you put onto it to get the car to run, and then once it's running you can do fine adjustments to get it running good. I'm going to give you guys some basic info and guidance on what you should do for bass tunes and go through some features that I like to change with any tune. Before we get started on the video though, I want to plug my store, swspeedco.com. Go check it out. We have t-shirts, we have lots of high quality 3D printed car parts, some universal, some stuff for Subarus, so go check it out, see if there's anything you'd like, and I would really appreciate it. So with that out of the way, let's get into the video. Before we get started here, before you do any tuning on your car, I would highly recommend reading this guide. I will put a link in the description below to where you can find this. This guide went missing for quite a while, but it just popped up again, so definitely is worth downloading, so you have it. I'm actually probably going to download this on my computer, yeah, just so I have it. I have a printed out version, but I don't have it downloaded. So this guide kind of gives you a lot of basic information on what you need to do with tuning, and it gives you a lot of good advice on some things that you wouldn't initially think of. It's a very good guide to read. It has a lot of good information. This was one of the first things that I studied in detail before I started tuning. This, as well as HP Academy or HPA Academy. They have really good tuning videos if you're more of a visual or video learner. If you guys want me to, I can kind of make maybe a video where I go through this guide and kind of try to clarify some things in here. So if you guys want to see that, let me know in the comments down below. But for this video, I'm just going to kind of freestyle it and just work through the maps on ECU Flash and try to get a bass tune set up and show you guys how I do that. If you haven't seen the last video, I showed you guys how to install Merp Mod patches on your factory ROMs or your modified ROMs. But what that does is it allows you to have two-step, flat foot shifting, speed density tuning, some other stuff, which is nice because you get those features without having to buy like an access port or something. So if you haven't seen that video, I'll put a card up. You can go check it out. What we're going to be doing, I'm going to be modifying that file that we have installed the Merp Mod patch on, so I'm also going to show you guys what things I changed with the Merp Mod patch. Also, one of the things I had explained in a previous video is that we saved our stock ECU tune to our computer in a safe location, and then we click Save As, and you save it under a different name, and that creates a duplicate file with a different name. So we modify the one that is the duplicate. So right now I'm going to open up the file that has the Merp Mod tune on it. And we're going to go through all these different maps on the side, and I'm going to tell you what things you should pay attention to, what things you shouldn't pay attention to, and kind of some things I like to change for a good bass tune. Your bass tune is all going to depend on what parts are installed on the car, and if it had a previous tune done on it, then at that point you'd be adding on to what already exists. If you're starting completely from scratch with a stock tune, and then let's say you just built up to stage 4, which is pretty unlikely, there's going to be a lot of stuff that needs to be changed on the bass tune. I think the biggest part of the bass tune is just to get the car running so that you can fine tune it. I'll be showing you guys those methods for fine tuning different features and stuff, and I'll try to give you guys a pretty concise and umbrella of bass tune. Starting from the top here, you have ROM info. Nothing is really changeable in here. This is just like some information about your ROM file. And then some of these categories, you can't open them. That means that they're not supported on your ECU. So you can see a lot of these Merp Mod: fueling, map switching, boost hacks, timing, miscellaneous. That stuff's not supported on here. I'm actually not sure what alpha means, but this first map here, this is a fuel efficiency correction. So this is what calculates the MPG you see on your display based on the injector pulse width. It knows how many times your injectors have been open, and that's how it calculates your fuel economy. If you're running like an aftermarket or standalone flex fuel system where it's kind of tricking the injectors into firing longer than the computer is telling it to, your MPG is going to be inaccurate, and also the fuel economy is different for ethanol. So you can kind of mess around with this and tweak it to get your MPG to be correct. I think this is a pretty useful map. So that's what that is. This is your ECU identifier, and anytime you change any values, this is basically, I think this is also called the checksum, but basically anytime you change any values on here, we'll change this number. That's how, like if you get your car smogged, that's how they know it has a tune on it and it's not a factory tune, is because a factory tune has a range of values that this number should be. So if you modify the tune, it's going to be different. But this isn't a file or a map that you will be able to modify. So we don't have to worry about that either. Also, something I should show you, we'll just click this one for instance, target boost map. In every map, you'll have edit, and there's like some different things you can do to it, and hotkey information. And then you can view a graph of it for a lot of these. So it'll give you like a 3D graph so you can see how smooth it is, if there's any like peaks or rough patches. Sometimes the visual will help you out with that. And there's also map help. This map help tab gives you a brief explanation of what the map changes and what it does. So those can be helpful too. Most maps have those features and they're just toggled on through this tab here. Okay, back to it. This table here is going to be your Merp Mod speed density table. So you'll only have this if you do the Merp Mod. I have not messed with speed density tuning. I haven't needed to. Speed density is useful for like high horsepower applications, mainly when you're like exceeding the map sensor, but it's not very good for like cruising. So a lot of drag cars with like big turbos or rotated setups will run speed density, but they don't have the best drivability. So this also allows you to do blending. So it uses the MAF sensor for like low load cruise, and then once it gets past that low load cruise section and gets into boost, then it'll switch to a speed density based calculation. So that's useful for a lot of people who are making big power. My car is in the realm of 500 wheel horsepower and I'm running straight MAF sensor. So it's definitely possible to do just MAF sensor. You don't have to do speed density, but I would say if you're going much higher than that, then there might be some benefits to switching to speed density. If you don't want to use speed density, these Merp mods, they come with some values in here, but these aren't to be used as like a base tune. You're gonna have to do some math to figure out what those values should be for your car. But right here, this right here where it says speed density mode, this is where you'll toggle like what mode you're in. So you can see right now it's in MAF sensor mode, and if I click the bracket key on the keyboard, it'll change it. So you can see here's the increment and decrement. You can use these bracket keys as hotkeys. This gives you all the hotkeys here. So you can either click it up there or you can do the hotkeys. So there's MAF and speed density blending, MAF sensor, and speed density. So we just have it on MAF sensor. So if it's on MAF sensor, we don't have to worry about any of these tables here. But if you do want to tune for speed density, this is how you do it. So maybe someday I'll make a video on that, but as far as right now, I don't know how to do it. Next one, this is going to be the Merp Rev Limit tables. This is where you're going to control your flat foot shifting and your two-step launch control. This first table here, you can pick between, I believe it's automatic and static and off. Yeah, so disabled, automatic, and static. So what static does is you set an RPM that it will cut back to when you shift, and it does that every time the clutch goes in. It like does another rev limit. So if you set it to like 5,000, it'll cut down to 5,000 before it kicks back in. I don't really like using static because the drops between gears is different for every shift. So I like to do automatic. Once that's set to automatic, you can come down to your gear ratios here, and it comes preloaded with a 6-speed gear ratio, but it's helpful just to look up what your gear ratio is. So I have a 2007 STI 6-speed in my car. So this rally spec PDF right here, this is a good one to get your specs from. It has the transmission code and like the model range. So, okay, so this is my transmission right here, TY856WW8MA. So here's my gear ratios. So we can cross-reference this to this. First one is correct. The second one is a little off. So this is why it's good to check. So if you want to change any value in the car, you can, the hotkey for that is equal, and it'll bring up this thing, and then you can just input whatever value you want into there. So my second gear ratio is 2.235, and then you press enter and it'll change that value there. Third gear is 1.52. So equals 1.521. Fourth gear equals 1.137. Fifth gear 0.971. So that's right. And then sixth gear 0.756. So that's accurate. So good thing to double check this. If you only have a 5-speed, I just put the final drive for fifth gear and then I just duplicate it on sixth gear, and that worked fine. So now the car knows our gear ratios, and then you'll see when you modify a map, it'll show up as pink right here. And that means that you changed that map and you haven't saved it. So once we save it and then like reopen it, it'll not be pink anymore. That's how I set up flat foot shifting, and then it knows the gear ratios and it'll cut to a different RPM depending on what gear you're shifting from. And I found that that's the like smoothest way for the flat foot shifting to operate, and I've messed around with it quite a bit. So that's the way I like to do it. So these tables you don't really need to change. This is just saying vehicle speed, minimum, maximum for these tables to be activated. So you don't need to mess with that. Don't need to mess with that. Rev limit, red line. This is your car's red line. So if you scroll down here to the bottom, right before the diagnostic codes, you'll see rev limit fuel cut under miscellaneous limits. You'll want to make this match whatever you have here. So I'll change this equals 6,700. And then, so the hysteresis, that's basically saying it'll hit 6,700 as the rev limit, and it'll drop down to 6,650, 50 RPMs lower, and then it'll give it fuel again, so it'll go back up. And so that's how, like, you hear some rev limiters are like bop, 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 really fast, and some are bop, 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 bop. That's the hysteresis. So 50 is a good hysteresis. I like that. So I also will change the hysteresis on the actual rev limit. So we'll change that to 6,650. So that matches as well. But that's just a preference thing. So now those are changed. And then we have our rev limit launch control. So this is where your two-step RPM is. And the hysteresis is also 50, which is good. I think a good start is 4,500. We'll set that to 4,500. But depending on your tune and mods, you'll probably want that in a different area. But 4,500 is a good area to start, and then you can mess around with it and figure out if you want to go higher or lower. These ones we don't need to mess with. So I don't mess with that stuff. This is for like if you have it in static mode, it's gonna drop to 4,000. That's the set value. Now we're good with this rev limit. We just changed the rev limit to match what our tune says. We set the launch control rev limit, and we set our gearing, and we have the flat foot shifting modes enabled in automatic mode. So we're done with that one. Now if you have these tables here, I don't know how to tune those ones, so you'll have to look somewhere else for that. My ECU doesn't support those. Alpha low pulse width injector comp, don't worry about that. Pretty much anything in blue here, don't worry about those. Those are kind of more advanced things, so don't worry about those. So here we get down to boost control. So if you're running stock turbo for a bass tune, you don't need to mess with any of this stuff. If you want to increase boost pressure, you can do that here. So this is what your target is set up to. So, you know, if I want to target 16 PSI, I can change that in here and smooth it out and stuff like that. But you kind of also have to know what your turbo is capable of as far as boost goes. And sometimes it may be able to hit 18 PSI, but the air temperature is so high because it's out of its efficiency range that running 16 PSI actually makes more power. So You kind of have to know these things and mess around with these things, but for most stock turbo cars, it varies. But I think 16 psi is a safe range for a stock turbo and a stock bottom end. You can change that here. All these other tables here, I don't really ever mess with. I only will change these target boost. I don't know the difference between target boost A and target boost B, so I just put the same values in both of them. And there's a lot of tables that are like that. Boost limit fuel cut, if you are going to be running higher boost pressure, you want to make sure that the car is not cutting at that boost pressure. And this is absolute pressure, so 32 minus 14.7. Okay, so this has a boost cut at 17.4 psi. So if you plan on running more than that, you're going to want to change these boost limits to be higher than your max boost pressure. Otherwise, you're just going to keep fuel cutting. The other tables in here, I don't mess with, just boost limit. Okay, so for a base tune, if let's say you wanted to increase your boost pressure or tuning for a new turbo, if you got a big turbo, a really important thing to do with a base tune is to set your wastegate duty cycles to 0, because you're going to want to start with 0 wastegate duty cycle, and then you're going to want to add in a little bit, and you just kind of want to trickle it in. And I'll get into more detail when I talk about tuning wastegate duty cycle. But for a base tune, big turbo, or just increasing boost, if you're increasing boost, you can leave it where it is and then do a pull and see if it hit your target, and then you can change the wastegate duty cycle up from there. But if you're starting with a big turbo from scratch, you're going to want to set all these to 0. So you would just highlight this whole thing, you'd click equals, and you would put 0. So the whole thing is 0, and you want to do that for the initial wastegate duty cycle B, initial wastegate duty cycle A, and max wastegate duty cycle. Set those all to 0, but we're going to leave those alone for now, just because this is an example. And if you ever make a change that you don't want to do, you can press Control Z, undo, or you can highlight a section. Like if I just wanted to undo this section, I can click revert, and it'll revert that section I highlighted. And then I can also do undo and undo, and it's back to where it was. Base tune for big turbo or any turbo changes, you want to start with 0 wastegate duty cycle and work your way up. Because let's say you put a big turbo on it and it has your wastegate duty cycle tune from your stock turbo that was, pushing 16 psi, you use that same wastegate duty cycle with a big turbo, you're gonna hit way too much boost and you're gonna blow up your engine. So you want to start at 0 and baby step up. That's how you safely tune your car. Also, if you change to a 3-port boost control solenoid, you're going to want to start with a 0 wastegate duty cycle, because those 3-port boost control solenoids, they need a lot less wastegate duty cycle to hit a boost target than the 2 ports do. So same thing, if you throw a 2-port wastegate duty cycle table and you throw a 3-port on the car, it's going to overboost. So we want to start with those for 0 in certain conditions. The rest of these tables here, we don't need to mess with. Turbo dynamics, you can change some of this stuff if you put a big turbo, but I've never needed to. My turbo's always spooled up fine, so I haven't messed with any of these tables before, so I wouldn't worry about them. Base tune, manifold pressure, sensor scaling, you only need to change this if you installed a new MAP sensor, and usually the manufacturer will give you the specifications to put into this table. Most of you probably aren't doing this on a base tune. Primary open loop fueling. Okay, so this is one thing I like to change on my tunes from the get-go for a base tune. So you'll see if I open up this map, you'll see it's very rich. So usually something I will do from the get-go is any value that's below 11, I'll set to 11. So all these values here that are in the 10s, I will just set these all to 11. And I'll just go through and do all those. So now there's no values in here that are below 11. And if we look at the graph, we can see it's a little choppy in spots. So we can smooth it out a little bit if we want, but for a base tune, I would say this is fine. The reason I put it at 11 is because when they're in the, oh, I missed some. The reason that it's so rich from the factory is because they distribute this car with this tune to tons of different countries, and the fuel quality is different for all these different countries. So they make the tunes really rich as like a safety feature. But if you live somewhere like the US or other places where the fuel quality is good and you know the fuel quality is good, you can raise this up to 11 and it's still on the rich side, it's still on the safe side, but your car will be a little bit happier. And then this primary open loop fueling failsafe table, it's a little different. It's just richer in some spots, and it'll do this if your car's knocking a bunch, it'll revert to this table. So I just leave this the way it is. It's a failsafe. You shouldn't be hitting it if your car is tuned right, but if you need to, it's there to help you keep your car from blowing up. So that's one thing I change. Okay, so that's it for that grouping. So for this closed loop fueling table, I don't really mess with anything in here, so we don't need to change anything there. So in this category here with the closed loop, open loop transition, the only tables I'm going to change out of all these tables is this closed loop to open loop delay and closed loop delay maximum engine speed. This says per gear. Those are the only two we're going to change. So I'll bring those up here so we can take a look at them. So for the closed loop, open loop delay, I'm just going to select all these equal 0. And this just makes it transition to open loop quickly. That just means it's going to go off of what is on that fueling table. And if you have the tune set up properly, you want it to follow what you are telling it to do. And having it transfer from closed loop to open loop quickly, it keeps it from having like weird lean conditions from the stock tune. Set to 0. Through here, it's like first gear, it'll only enter open loop at past 5,000 RPM. So if you romp on it at 3,000, it's still going to be in closed loop fueling based on your O2 sensor. So for all of these, I just set them to 2,500. This is kind of a complicated like network of maps that's referenced, but what this allows you is once your car is past 2,500 RPMs, it allows you to switch to open loop fueling when needed. It's just a more consistent tune, and you're not going to romp on it below 2,500 RPM. So anytime you romp on it, it'll quickly switch to open loop and you'll get the correct fueling that you tuned for. So those are the two things I change in this category here. Fuel injectors. So these blue tables, don't worry about those ones. You have to have some crazy like EGT sensors on each cylinder to be able to tune this kind of stuff. So for most people, they're not going to be doing that. And if you are doing that, you probably know more than me anyways. The only tables you'll need to tune here are injector latency, injector flow scaling. So if you have stock injectors, you don't need to change any of this for a base tune. But if you upgraded your injectors, this is something you're going to have to change for your base tune in order to get your car to run. Usually, your injector manufacturer, if you buy from a good company, they'll give you specs for your injectors, and you'll just input those values here. So these latencies are based on battery voltage. So if the battery voltage from the manufacturer are different, you can change these battery voltage numbers, and you can change these numbers too. So you can just change this to match the manufacturer's data, as well as the injector flow constant. So this is also called injector flow scaling or scalar. So you'll find a value through your manufacturer and you can input that number here. And it just lets the car know how big the injector is. If you have stock injectors, you don't need to change this. Blue tables, don't worry about them. Throttle tip and enrichment, this can be tuned. It's a bit tricky to tune from what I found. In most situations, you don't really need it. It can help with throttle response and like big turbos and stuff like that. But it's kind of just really tricky to tune. And then this whole warm-up enrichment thing, they're all blue tables. Don't worry about them. The AF learning limits, we leave this alone. That's just how much it can change the fueling to get the right air-fuel ratio. But this table I like to change, and this is a big safety feature in my opinion. So what this is saying, there's 4 different ranges, A, B, C, and D, and it will apply a blanket AF learning change for those ranges based on its feedback from the O2 sensor and stuff. And with this current setup, what it allows it to do is it allows it to change the fueling based on what it's learned in the wide open throttle range. So what these current airflow ranges do is they allow it to change the fueling when you're in open loop fueling. So if for some reason your car is running a little a little rich, you know, at 38 grams per second, then it'll, you know, remove some fuel to make it run correctly. But when you romp on it and you get into wide open throttle, it's still pulling fuel in wide open throttle. And that's not good. If you had it tuned properly, then you're running lean. So that's not good. What I like to do with this table is basically artificially disable the range D so it can't make changes in that airflow range. I like to set the A to B range equal to 10. I like to set the B to C range equal to 40. And then the C to D range, I like to set to 80. So I learned this from the HPA Academy. And from what I understand and remember, what this does is it makes it so, I think these trim learning tables are calculated during closed loop fueling. In closed loop fueling, you'll never hit 80 grams per second, so you'll never get any fuel correction in this range right here. So that keeps it from having any fuel correction when you'd be in wide open throttle. So that's the idea behind this, is it's artificially limiting its ability to make changes in that airflow range. That's a must change right there. If you have any intake changes, any changes to your intake, you'll be doing all of your tuning. If you have like a new cold air intake, all of that tuning will be done here in the MAF sensor scaling table. It's kind of hard to get a base tune going for this. The only way you can kind of figure that out is you can take the diameter of your stock MAF housing and the diameter of your aftermarket MAF housing. You can find the percent difference between the two. So let's say your new intake is 20% larger than your stock one. You can multiply all the values in this table by 20%, and that will get the cruise kind of set up where it needs to be. But usually I found that it makes the top end kind of rich. So usually what I'll do, and I'll show you guys MAF scaling, but usually I just leave this alone and the car will run. It'll just be making like large corrections, and then you just make changes based on the corrections to dial it in where you need. So this isn't really something that you need to change for your base tune, but if you're doing an intake, you do need to tune MAF scaling. Also, if you run a big turbo, you might need to increase this number here. This is also a good thing to change on a base tune, because chances are if you're doing a lot of modifications, you're probably going to max out the mass airflow and hit the limit, and it's going to throw a check engine light. So we can set that to 400, and that'll be okay for the base tune. And then MAF sensor scaling, if you have a new intake, you can tune that later, but it'll be able to start with the factory MAF table. So you don't have to worry about that now for the base tune. So that's the only thing in this category that we need to worry about. Okay, so now we're into the timing. So base timing, if you did any big changes, like a turbo or increasing boost or something like that, what I like to do just as a safety is from this 1.5 grams per revolution onward, I'll just highlight this whole table. I like to click add to data, and I'll put -4. And so I'll remove 4 degrees of timing across the board from here, just so if your boost is higher, you're not knocking. It's basically just putting a little safety there to keep your car from knocking. Once you get your boost tuned in and stuff, then you can bring it and trickle in back more timing and even add some more if you want. But we'll go over that further. But for a base tune, if I made any big changes, I always like to pull a little bit of timing out just as a safety. So that's something I like to do. None of this other stuff I change. All that stuff is good. Timing compensation, this is the table that I use to tune my anti-lag system, but we're not going to do that for a base tune. This is all not control strategy. The one thing I do like to change in here for a base tune is this advanced multiplier initial. So when you start your car, it's going to be at a 0.50. So based on this value, it'll change how much timing you have and stuff. So the car is going to be lower power. And then once it sees that your car is not knocking, it'll feed back in some of the timing. But for tuning, it's really annoying to have to wait for that value to get to 1. So I like to change this so that it just starts at 1. And then if it has an issue, it can pull the IAM. If you have an IAM dropping below 1, there's something wrong with your tune. So just having it set initial 1, no big deal. It's the best way to tune for that. So that's all I changed for a base tune in this category here. So variable valve timing, you don't need to change any of this for the base tune. drive-by-water, throttle. I've never changed any of that stuff. The rev limit, I changed the hysteresis as you saw earlier. So speed limiting, if you want to enable or disable this, this is a good time to do it for a bass tune. So you can see the car is electronically limited to 140 miles per hour. So if you hit 141 miles per hour, it'll cut fuel, and then it'll resume fuel at 138 miles per hour. So that's how it keeps the car from exceeding 141 miles per hour. So if you want to disable that, you can just set this to a value that your car is not going to be able to reach. So I can select this number here, change it to 200, let's say, and then we'll do off below. We'll change it to 198. And then for this one, it's the same thing. So we'll put none below equal to 198, and then high above 200. So that basically removes the speed limit. That's a good thing to know too. These are just miscellaneous temperature sensor scalings. Don't need to mess with that. Don't need to mess with any of this. Idle speed. This is a good thing to change if you have cams or anything else that makes the car idle a little rough. Like my car has stage 2 cams and they don't like to idle low. And I was having issues with it idling low. The car still started, so you don't need to change this for a bass tune, but if you put cams in your car, I think it's a good idea to raise these to 800. So I'll just select everything that's below 800 and set it to 800. And then I'll do that with all these tables here. I don't know what the different tables do, but there's 3 different tables. So I just changed the bottom value to 800. And that helped with cams a lot to help it idle. So all those changed to 800. Good bass tune there. Force pass readiness monitor. We don't need to mess with that. So this is going to be all of your diagnostic and check engine light codes here. Depending on the mod you did to your car, will depend on if you need to disable these, but a lot of the times you'll find out if you need to disable one because you'll start your car and a check engine light will pop up. You'll read it, see what the check engine light's for, and then you can go in here and disable it if it's not something you need to worry about. Okay, so if you did any fuel system modifications, you did the parallel fuel system setup, and maybe you're not hooked up to your evap system anymore, you might get some evap check engine lights, so you'll come in through here and you can disable those. I don't know which ones are necessary to disable, so sometimes it's often easier just to start the car and see what check engine lights pop up and then disable the ones that popped up, and then you're not disabling unnecessary things. If you removed the EGT sensor because you have an aftermarket up pipe and you don't want to run the factory EGT sensor due to risk of damage to the turbo, you can disable those check engine lights right here, and I'll just show you how to disable those. So when you come up here, you click on the check engine code and it just shows this thing. It says enabled. So you can click on this, you can go into here, you can click increment, and it'll change it to disabled. Edit, increment, disabled. And those 2 check engine lights are now disabled. And you can see that they're pink. So if you did TGV deletes, you're probably going to get all of these codes. So if you do TGV deletes, you can come in here and you can disable all these TGV codes. But as far as disabling check engine light codes, it's all kind of based on what mods you did, and you don't need to really disable them to get the car started. So that's pretty much it for a bass tune. There's little things you want to change and little safety nets you want to set up so that when you are tuning your car, you're not going to have any surprises that blow up your engine. So with that information that I just gave you, you should be able to get your car started and then see what kind of changes the car is making, and then make changes and adjustments based on those, and just doing a reiterative process of that, you'll get your car tuned nicely. Again, if you want me to go through this Bad Noodle tuning guide, I can do that for you guys. Just let me know in the comments down below. The next video, I'm going to be talking about MAF scaling. MAF scaling is the most important thing to tune, and it's the first thing you tune, because all of the other tables that you're tuning are based off of your MAF scaling, and you're making sure that your air-fuel ratio relationship is correct. So if there's any tune table you're going to spend the most time on, it should be MAF scaling. A tune that has a bad MAF scaling table is going to be bad. There's nothing you can do to the tune that's going to make it good. If the MAF skilling's bad, the whole tune is trash. So it's very important to get the MAF skilling dialed in perfectly. So in the next video, I will show you how to tune MAF scaling. I do have an old video where I showed you how to do MAF scaling. I have a new method of doing it now. It's a bit more streamlined and easier, and it takes less time. But I'll put a card up here. You can go check out the old MAF scaling tuning video, but the new MAF scaling video will be coming out short. So I hope you enjoyed that video. Hopefully you can get a bass tune going and get started on your tuning journey. If you did like the video, please leave a like. If you have any questions for me, leave them down in the comments below. If you aren't subscribed, please consider subscribing. And if you know of somebody who might like this video, please share it with them. As always, thanks for watching, and I'll see you on the next one. Peace out.